Okay, Charlie here, doing my walk this morning. I noticed I'm not carrying the backpack. With there only a couple of weeks left to the trip, I'm trying to kind of let my feet and ankles heal up from any stress that might be caused by toting the backpack just for exercise. I'm still walking a lot and everything. And I can tell you, as the date approaches, I've been having lots of worries about little weird things because people keep telling me, aren't you afraid that somebody's gonna do blah blah to you or something? And the possibility crosses my mind. I'm probably more afraid of hailstorms and bears than I am anything else, but this has gotten me to started thinking about weird small probabilities of things happening and how you deal with those. And so the math nerd into me is going to talk about Bayesian statistics for a bit. So strap in, this is fixing to be a math lesson. So what is the Bayesian statistics? Let's say I had gone to an exclusive engineering school and they're having a reunion and they have exactly 1,000 people show up. And we know that of this 1,000 people, most of them are engineers. And so 90% of them, in fact, are engineers. And we also know that of the mathematicians that showed up, most of them are poor. In fact, 80% of all mathematicians are poor because, you know the joke, what's the difference between a large pizza and a theoretical mathematician? Well, a large pizza can feed a family of 4. But anyway, so 80% of the mathematicians are poor, but only 10% of the engineers. So I encounter somebody and I look at him and I say, that person's poor. And so immediately, since 80% of mathematicians are poor, I jump to the conclusion that's a mathematician. But would I be correct? So let's think about this for a second. So the way the Bayesian statistics works out is that if I really want to look at this, I have, there's 80% chance that this person is a mathematician and poor, and there's a 10% chance they're a mathematician. If I multiply those two together and divide them by the probability that the person's poor, so let's think about that. There's 10% of the engineers are poor, and you add that to the 80% of mathematicians that are poor, you come up with 170 out of 1,000, which is 17%. So you divide by that, and this gives you the percentage of 46%, which literally means that being able to assume mathematician, given the fact the person's poor, I only have a 46% chance of being right, or slightly worse than just flipping a coin. Okay? And that's kind of how Bayesian statistics work. There's a famous example where they do the 0.1% or 1 in 1,000 and the 99%, and you get to see the extremes of this. So let's say you have a child and you notice your child is exhibiting weird behavior, like the only thing they want to play with are the attribute blocks that your weird uncle gave them and stuff. And they also are always putting everything in sets and groups and stuff. And so you take the child down and get them tested, and the doctor tells you, your child has a really rare condition that my tests have identified, and that's that your child's going to grow up and be a huge math nerd, because in this set of conditions, it's only like 1 in 1,000 kids have this. And you're like, oh no, I was kind of hoping for somebody who'd be socially successful and stuff, not a huge math nerd. But, if that's what I get, that's what I get. But you ask the doctor, so how accurate is this test? And he goes, oh, this test is 99% accurate. And so you walk out of there thinking, yep, there's a 99% chance my kid's going to be a huge math nerd. But let's look at these numbers. First of all, there's the 0.001 that your kid is, has this condition, right? because it's only 1 in 1,000. But the test is 99% accurate. So if the test is 99% accurate, that means the 1% of the 999 that the test didn't identify accounts for basically 10 people, which means your sample set is about 11, right? And so you have a 1 in 11 or 9% chance that your kid will be a huge math nerd. And so it's really not all that high, considering that the test was 99% accurate. And so, you know, that's probably one of the reasons why mathematicians are so rare. That and the fact that evolutionary pressures, when you started talking math stuff around the campfire back in the cave, everybody just chunked you out in the cold and you died or something, I don't know. But anyway, that's Bayesian Statistics. If you want to know more about it, you can look it up. It's spelled B-A-Y, Bayesian. And so, I can't spell either, but that'll give you something to think about. And that's literally how mathematicians worry about trips that are coming up.